Hello everyone, I hope everyone is doing well and so far enjoying Chicago Roboto. Welcome to the plugin development and automating models creation session. In this session, we will be talking about plugin development and models creation. But before that, something about me. So my name is Abdul Basit and currently I am working at SWVL as an Android engineer, and you can reach out to me at my Twitter handle. So regarding the today's agenda, so first of all, we will be looking into plugin development, how you can create a plugin. Then we will look into live templates, and after that, I will be explaining how we build a functionality on top of Json to Kotlin plugin. So regarding starting the plugin development, so you have two ways. Either you can use a GitHub template, which is being provided by JetBrains teams, and or either you can use Gradle. So let's look into the template file, the plugin template. So you can find it at JetBrains/IntelliJ platform plugin template. So the advantages of this plugin template is that it speed up the whole process. It has some pre-configuration and project scaffolding and CI and different code symbols and unit tests. So like you don't have to add them by yourself. So either you can use this template, but if you don't want to go for the template, so what you can do that you can create a new plugin from IntelliJ. So what you have to do that, go to files, new project, and from there you select the IDE plugin. So if you want to create a theme, select the theme, but as we are looking into plugins, so here you select the plugin. And regarding the language, so you can go for both language. Either you can go for Java or you can go for Kotlin. So when you click on the create, so this is the structure that has been created. Just ignore these files because I have added those, but apart from that, everything will be same to same. And if we look, so this is the structure is same as Android applications. So we have our package, uh, we have resources, and then we have meta information. This is a new thing, and then we have build.gradle and settings.gradle. Now let's look into the build.gradle file. So in build.gradle, we have first we have declared all plugins, like we have Java, we have IntelliJ, and we have Kotlin. Then we have repositories, and here we have the IntelliJ tag. So this IntelliJ tag, whenever we are debugging our plugin, or uh, we when we are debugging our plugin, so it will when we run this, so a new instance of the IntelliJ will be created and the plugin will be running in that instance. So here we are setting this version to 2021.2, and then we are setting the IDE type. And sometimes what happens that we might be extending the functionalities of some existing plugins, like Android Gradle plugin or some others that are already pre-made, and we want to extend those functionalities, or we might depend on those. So for that, what you have to do that you have to list those dependencies here, those plugin dependencies here. And then we have the dependency tag. So here what we can do that we can list all our dependencies, and we can use the Android cores one, like we can use retrofit, we can use RX Java, we can use Kotlin coroutines and different dependencies. And then we are setting the compatibility version and the page plugin XML. This tag sets the upper and lower limit. So if I talk in the context of Android development, so we have minimum SDK and the target SDK. So this here we are setting the version, the minimum version, that it shouldn't be compatible with versions lower than that. And here we are setting the until build, so it will be available until this version and not onwards on that. And regarding the range number, so this is a shortcut for the IDE versions, and regarding that, what you can find more details on this link. And then we have signed plugin, so it is same as creating a signed APK. And in Word, what we do, we create a signed dbk. So this will create this task will create a signed plugin, and then we can publish our plugin. So as we publish our applications to the Play Store, so same we can publish our plugins to the JetBrains marketplace. So this was regarding the build.gradle file. Now let's look into the plugin.xml. So the plugin.xml, it is kind of manifest for plugins. Um, if we declare some services, some listeners, or uh, any other component, so we have to declare it here. So first we have the ID, we have the name, and then we have kind of different, we have descriptions, we have vendor. And as I mentioned that sometimes we depends on some plugins. So here we have to declare those, and then we have application listener, which we will be covering in the upcoming slides. Then we have the actions and these things, and we also have a plugin icon. So this is the icon that will be displayed on the um, IntelliJ JetBrains marketplace. And here also, like if I go to the preferences, and there will be different plugins. Let me search for plugin. Yeah, here it is. So there is the icon. So these are the icon that is gonna be displayed. So this was, and there are kind of different guidelines regarding the plugin icon, that it should be 36 cross 36. And if you want to add an icon for the dark mode, so you have to name it plugin icon underscore dark. So this was all regarding the plugin icons. Now we will look into different uh, plugin structure components. So we have like different plugin, like as in Android, we have activities, we have fragments, and we have like of course receivers and different things. The basic building block of Android. So same for plugin, we have some building block components. So we will explore some of them. So first of all, the service. So service is kind of a component which is loaded on demand whenever we call the Git service. So we have application level services, we have project level services, and we have module level services. So regarding the application level services, so these are the services which runs the life cycle of the application. So whenever you open the ID, these are the services that you can get, and these will maintain until you close the IDE. So these resides in the uh, application life cycle. Then we have the project level services. So these are the services that runs in the life cycle of the project. So whenever you open a new project, so these service will available, and when you close those, so these will get destroyed. And then we have module level services which are available for each module. So normally they discourage the module level services, because like suppose if you have 100 or 200 modules, and for that you are creating multiple services, so it will heavy load the IDE and will slow it down. So that's why they discourage those. But we so this was all regarding the services, and let me give you an example of the service. So we have an OpenMax project. So here we are creating a service. So we have a service which is called project counting service. So we have an counter whenever we open a project, so it will be incrementing that count, and whenever we close a project, so it will be decrementing that count. And then we have the project limit exceeded function. So here we are saying that the upper limit is 3, and whenever we open more than 3 projects, so when we call this function, so it will return true. So as I mentioned that whenever we declare something or we add something, so we have to add those to plugin.xml. So same goes for the application level services. So we have added an extension tag, and inside that we have added our application service, and it is pointing to our service class. And if you want to create a project level service, so just replace the application service with project service. So in this example, our service uh, is being communicated by listeners. So let me explain the listeners. So like as you do in Android, that we can subscribe to different events, and we can subscribe to different events or broadcast receivers. So same goes for these listeners. So these listeners are kind of events that are delivered through message bus, and we can subscribe to them. And we have application level listeners and project level listeners. So I have already added a listener, so let me show you that. So we have in a project open close listener. So this is a class, and as I mentioned that we can subscribe to different events. So for that you have to uh, implement those interfaces, those event interfaces. So we have a project manager listener. So whenever a project is open or closed, so we will be getting a callback. So when the project is open, what we do that we increment our count. And regarding getting the services, so you can get the service by calling get service class, get service method. So we increment the count, and here we are checking if the project count limit has exceeded. So show a message dialog. And when the project is closed, so get the service and decrement the count. Now let's look into it in and the same is services. So we also have to declare the listeners inside our plugin.xml. If I click on it, so as you can see that we have added an application listener, and then we have a listener tag. So inside that we are pointing to our class, and we are subscribing to a topic. So we are subscribing to the topic manager listener, and we have implemented that interface uh, in our project open close class. So there are multiple topics that you can subscribe to, and like we have application level listeners and project level listeners. And let me run this so that I can show you it in action. So as I was saying that whenever you are doing some development, so it will create a new instance of the IDE. So here you can see that a new instance has been created of the IDE, and the version is 2021.2. So there is already a project open which is called project 1. This is an empty project, and now let me open other projects. Now we are opening project 2 in a new tab. This is project 2 being open, and now let me open project 3, new window. And now let me open the third project and the fourth project. So with the fourth project, we should be able to see the message, and here we can see that the message is being displayed. And let me drag it from this screen to, yeah. So here is you can see that the message that we set is being shown. So this is how the listeners and the services works. And like as we are opening multiple projects, so our application level service state is being maintained. So there are multiple use cases for those, like if you want to. So there are multiple use cases for those, like if you want to send something on whenever the application is started, or if you want to check for versions and update those, or there are like multiple things that you can do with those. And then we have another component which is action. So actions allow us to add different like menus to the toolbars and to the menus. So via actions we can add items to the menus and toolbars. So let me give you an example of the action. So here I have already implemented a demo action. So whenever you want to implement an action, uh, so what you have to do that extend that class from an action, and whenever the action is being clicked, so you will be getting callbacks for action performed. And here we have created a demo action, and then we are showing a message dialog. Now if I click on it, so same as services in listeners, we also have to declare those actions inside our plugin.xml. So here I have added an action. We have the ID, we have the class, we have the text, we have the description and the synonym. So synonym is the text, the alternative text that you can search your action for. And then whenever we have an action, so like you are adding a menu or something like that, so you have to anchor it somewhere. So here we are anchoring it to the help menu, and it should be anchored first. And if you don't want to can do that manually, so you if I delete those, so if I go to the demo action, if I click on option enter, so there I can register action. So as you can see that we can name it, we can call it demo action, and then this is the description, and there are multiple groups that are available, like we can add it to the help menu. So here you can see that this is the help menu, and there are multiple actions in the help menu. So we can like anchor to them also, uh, like we can anchor it first, last, or before or after. So we can also do that, and then you can add a shortcut for your action. So like we have a shortcut for copy and paste, so the same you can also add a shortcut for your action. So we have already added the action here, and as the instance is already running, so I will show it here. So here we have the help, and inside help you can see that we have the demo action. If I click on it, so I'm able to see a message. Now, this was regarding the demo action, and the other thing that I wanted to highlight is the usage of the synonym. So we added the demo action in the synonym. So if I search here demo action, so I should be able to get that in here, and I can trigger it from here. So as you can see that we have demo action, and when I click on it, yeah, the message is being displayed. So this is how you can add an action, and then you can also add a new group. So here we are assigning a new ID and new text. So same as action, we also have to anchor or group somewhere, because they will be relative, so we have to add it to a group or somewhere. So in this case we are anchoring it to the main menu, and as you can see here we have our new group, and then we have group demo action. So you can like do multiple things. You can do nested menus and these things. So this was all regarding the action. Now let's uh, now let's look into our problem. So normally what happens that like we are using clean architecture. So for each layer we are using different data classes. So we have presentation layer, we have domain layer, and then we have data layer. So for each layer we have different classes like UI models, entity models, and remote model. So normally what happens if you get a response, so we create the response model via Json to Kotlin plugin, and we are using Moshi, so they are Moshi annotated. And once we get that, so what we do that we copy paste that remote model, and then we map it to the we convert it to the entity model, we remove the annotations and replace remote with entity and extend it from entity model. And then we, after entity model is being created, so then we have to create the UI models. So then we copy the entity model and convert it to the UI model. In case of a simple response, it's quite easy to just copy paste and copy paste those data classes. But in case of a complex response, so it gets quite difficult. Like you have to copy paste all those models, then you have to remove the remote and replace it with entity, and then you also have to write mappers. So you have to we need a mechanism to convert from one state to another, from one model to another. So we have to convert remote to entity and entity to the UI. So you have to also write mappers. Now, if I talk in the context of our implementation, so whenever we have to implement an API response or a new feature, so for that, what we do that we create a new data class module, and inside that module we implement the remote and the entities and the UI classes. This is a convention that we are following. And when we create the data classes modules, then we add those data classes into our features modules. So we have like around 120 modules, and uh, like the sync takes around 20 to 25 minutes or more than that. And sometimes what happens that we have a typo in the declaration. So you are waiting for the project to be syncing, and after some times you get an error that I am unable to find that module. Or what happens that you forgot to add Moshi code gen. So the code compiles, and when you hit the API call, so your application crashes, and then you realize, oh, I forgot to add the Moshi code gen. So then you have to wait again for 30 to 40, 30 to 20 minutes. And like we are looking into optimizing or the sync process, but it's on. So we are looking into optimizing that time, but still, like the mapping and the copy pasting, it takes quite a lot of time. So the initial solution that we looked for was live templates. So live templates is kind of a template that an option that IntelliJ IDE provides. So in live templates, what you can do that you can create variables inside those live templates, and then you can apply a regular expression on those variables. So let me show you the live templates. So here we have the search for the live templates, and there with the plus icon, what you can do that you can add live templates or templates groups. So here I have already added a live group, a template group with swivel, and then we have entity models. Now let's explore that. So as I mentioned that we can have variables. So here you can see that we have an entity variable, we have remote parameters variable, cache parameters, and item parameters, and then we have mappers. So we have entity variable, and then remote mapper, then we have cache entity, and cache mapper, then we have entity, and UI model mapper. So like you can see, if I talk about the conventions of naming or model, so we have, whenever suppose we have a user response, right? So it's the in the remote data class, its name will be user remote, and the cache, its name will be user cache, and user item, and user UI model. So we get the name, and we just add or concat the layer name with that model. So here we have an entity, and whenever we enter the entity, so it will map with all the variables, and it will automatically convert it to remote, to the cache, into the item, into the UI model. And as I was saying that we can apply different regular expressions or different expressions on the variables. So here we are applying an expression on the entity. So whenever the entity is changed, so it will automatically convert it to the camel case. Then we have remote parameters, so we are not applying any expression on the remote parameters. Then we have cache parameters. For the cache parameters, we are uh, applying a regular expression, so whatever the remote parameter is, but if there is a remote, so replace it with cache. And for the item parameter, so here we are replacing remote with item, and here we are replacing remote with UI model. So we are just concatenating, like in case of parameters. So like suppose if I have a parameter with the name user data remote, so it will automatically, the cache, this regular expressions will automatically convert it from user data remote to the user data cache and to the user data item. And regarding the mappers, so here what we are doing is like we pick the item parameters, and then we uh, apply an regular expression on them, and we remove all the uh, all the slash in slash t or word, and we just leave the variable name, and we concat with equals is equal to do. So this is how we are mapping the parameters. Let me show you that in action. So if I go to live template, so here if I enter the entity models, so as you can see that this live template has been created, and uh, without the variable name. So if I enter a variable name user, so as you can see that it is being mapped to all of them. And if I click on enter, then suppose if there is kind of string or something like that, like integer or not a custom object, so it will uh, map that accordingly. But uh, if we have a custom object like user data, and if I call it user data remote, so as you can see, as soon as I complete the remote, so it is automatically mapped into the cache, to the item, into the UI models. So this is how we were using the live templates. So the live template solves our problem, but not totally. As you can see that we have all these files, uh, all of these data classes in just one file. So what we have, then we have to manually move them to their desired layers. Like remote, we have to kind of copy it, cut it from here, and create a new class, and call it user remote, then user cache, and these kind of things. And then we also have to move the user cache. So then we were looking for some other solution, that how we can automate this whole process so that we don't have to manually move the files. So now as you can see that we have to manually move these classes. So we were looking for a solution so that it can do all the process automatically. So then we thought of building something on top of Json to Kotlin plugin. So for that, what we want to do, like we have to, first of all, we wanted to create individual files. So for that file, for creating individual files, what we have to do, that we have to split our lab templates into multiple parts, because we will be creating uh, a file for each data class. So we wanted to split it. So this is so we split this into another template, this to another, and this to another, and then mappers to another. So for each object, we have to create 5 classes: remote, domain, and in remote, domain, and UI, and then two mappers from remote to domain, and from domain to UI. So we split that up, and uh, we split up those classes, and then like we created a templates like this. So is when I was giving the demo of the live template. So if you remember, we were just entering two things. We were entering the name, and then we were entering the variable and then we were entering variables. So here goes the same thing. So we split it up, that live template, into a string, and what we do, that we will just enter name and the data class parameters, and we should be able to do that. So we created all these 5 files templates, and then what we did that whenever we build a functionality on top of JSON to Kotlin plugin, so we use their dialog, and whenever the generate is being clicked, so from the JSON to Kotlin classes, we get the response model. So in the response model, we get that what is the file name, what are its subtypes, and we also get the file body, that this is the created class. So we apply regex on that. From there we extract the name and what are the parameters, and then we just do the live template thing, and we replace the variables at runtime. So in each template we have a variables, like here you can see the name and the data class parameters, so we just replace that at runtime. So this is how we were doing the whole process. So now we created the file body, like we have the string that we wanted to create and the name of the file, but now we have to create files like on the desk. So for that we use the PSI APIs. So the PSI it is kind of a virtual file system provided by the JetBrains. So via that, what you can do that you can create different files, you can modify the existing files, or you can delete different files. So first of all, we wanted to create specific directories, because our different layers will reside in different directories. So first what we do, we find the directory, we look for directory. If it already exists, so we add, we return that directory, or otherwise we create the directory. And when we are in the desired directory, like we are inside the domain model or in the remote layer, so then what we do, we create a file with the PSI file factory. What we can create a file, all you just have to provide is the file name, what is the type, and then the content of the file, like what you want to write inside that file. And then we use the style manager to style or to uh, format or code, and then with the psi directory.add, the new file is being added, and this is the resulted class. So as you can see that we have the user remote, which is Moshi annotated, then we have the UI model and entity models, and they are same to same, like just with the entity and UI model name. And then we have the mappers. So all of this process is done at runtime. So let me show you the example. So let me first copy a simple response. I'm trying to get a simple JSON response so that we can generate classes from. So now I have got it, and if I go here and I file and new remote, so we have added a new action. So as you can see that we have the normal JSON to Kotlin plugin action, and then we have added ours one, Kotlin remote UI and class entity file from JSON. So it's quite long, but so when you click on it, I uh, paste the JSON string, and it is like we are reutilizing their dialog, but just with uh, two inputs. So we have package, so sometimes we want to create a new module. So if there is something in the package, so it will create a new module, and then is it an Android module. So because we are adding a new module, so sometimes there might be dependencies on Android components. So for that we add the Android tags. So let me call it, the name will class will let me name it attributes data, user data. You can call it user class, and then for the package we can call it the module, we can call it user data classes. And when I click on the generate, so as you can see, all of these files are being generated automatically. Now let's explore them. So as we enter the module name, so a new module has been added, and build our Gradle file. Here we are having some plugins like Java, Kotlin, and Kotlin capped and dependencies. And now if we look into the remote one, so we don't apply any formatting or anything like that on the remote data classes, because they are pre-generated by the Json to Kotlin plugin. And then if we look into the entity model, so as you can see that these are the classes that are without any annotations. We just added concatenate the entity and remove the annotations via regex. And then we also have mappers, so we can also map from one, and you can see that body is equal to body. So in most of the cases, like the entity and remote will be same the variable, like 90% cases, but sometimes we need to change them, or we need to kind of apply some logic, so you can do that manually, but by default they are pre-mapped. And sometimes we have nested mappers. So this is a nested mapper. In this case, we have like an object, but inside that object we have another object. So for that we need to first declare the mapper, and then we can map that. So how we identify that this is a custom object? So when from the JSON to Kotlin response, there we like for each class we get what are its sub properties and what are the types. So from there we check if it is an object or it is in a list. So we declare those mappers, and then we map them accordingly. As you can see that we have a list, the data is a list, and then we are mapping it accordingly with their own mapper, and we have declared their mappers. So this is how the whole process is done. And the other thing that I wanted to highlight is with the PSI files, you can also modify existing files. So earlier, when we used to add, we used to create the module manually, and then we have to add it to the settings.gradle file. But now with our own action on top of that, so what we do, we add that module in the settings.gradle file automatically. So this was all regarding the plugin development. And now regarding the references, so first of all I would like to mention Marcos Salgado. So when I was looking into plugin development, so I stumbled upon his tutorials regarding the plugin development, and these tutorials are amazing. And then he also has a talk, and this talk is inspired from his talk. And then we also like regard for creating the templates in these things. So we are also a blog post on the pro Android tip regarding automating and creating files for a new screen. So this is also an amazing repository. You should explore that. And the IntelliJ documentation is also quite well explained, and there are also code samples. The project, the open close counting. So I picked it from the code samples. And uh, if you have some issue or you want to ask any questions, so there is also a Slack channel for the plugin development, so you can also join that. So that is all from me, and thank you so much for thank you so much for listening to me, and thanks to Chicago Roboto for giving me such an amazing opportunity to share my knowledge. And thank you so much. Now if you have any questions, I'm open to, you can ask. Thank you.